Hello everyone. Today let's solve the problem number 1143, longest common subsequence. So what the question states here, we are given two strings. So here you can clearly see text1 and text2. We are given two strings, text1 and text2, and we need to find the length of the longest common subsequence. We need to find the length of the longest common subsequence. Here ACE they have given, here ABCDE it is there. So the length of the longest common subsequence here is 3. So we have to return its length, right? Length 1, 2, 3. ACE is present in both text1 and text2. So the length of the longest common subsequence here is S and its length is 3. That's what they have given here. So what is subsequence here? A subsequence is formed by deleting some characters from a string without changing the relative order of the common characters. So they have clearly mentioned here this one, right? So either we can here we can delete B and we can delete D. That's what we have done here. So we cannot change any subsequence. We cannot put B to here or D to somewhere and use this this one text1 string. No, we cannot do that. Either we can delete any character and then consider the characters within the particular string, right? That's what we can do here. In this case we have deleted B and D. ACE and ACE are common here, so the length here is 3. So that's what we need to return. I hope this is clear. Second example, here same thing goes with here as well. So text1 ABC is there, text2 ABC is there, both the string match here, right? ABC matches ABC here, so the length we need to return as 3 here again, right? So let's come to the third example. Just give me a second here. Let's come to the third example here. Third example, here we have ABC and DF. All the strings, all the characters within the strings are completely different here. So the output we need to return in that case is 0. So I hope this is clear. All the three examples are clear, right? So I hope the question is completely clear. So initially what we will do, we will discuss the approach followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. So first thing here is we will discuss the approach. I will consider the same example, the first example that they have given in the question, right? So let's discuss the approach. Let's discuss the approach step by step. So the approach that we'll be going with here is, so here we are going with the dynamic programming approach, right? Just keep this one in mind. The example, I have considered the same example, the first example that they have given in the question. Text 1 is ABCDE and text 2 is ACE here. So we know that output is 3. We have already discussed this one. We have ignored B, we have ignored D. So ACE here, ACE. So both matches here. They have clearly mentioned in the question. We can remove the character that is present in the string. We cannot change the sequence, but we can remove the this one. We can ignore or remove the characters in the string to match, right? Here ACE. So the length here is 3. So that's what we need to return. So let's come to the step 1 here. In this case, the base case first here is, so let's discuss the base case first here. Before base case, we are going to create the DP table. So we are going with 2D DP here. Just keep this in mind. We will create 2D DP table. Just remember this in mind. Base case here is, let's initialize the base case. If either text1 or text2 is empty, then length of the common subsequence here is will be 0, right? Because empty string has no common subsequence with any string. We know this one, right? So here either this one is empty or this one is empty, then answer is 0. We saw this one in the third example in the question itself. We have already discussed this one. If either text1 or text2 is empty, then longest length of the longest common subsequence is 0, because again I am telling empty string has no common subsequence with any string. We know this one, right? So this is second step. Let's move to the final step. So let's see the DP table implementation or filling the DP table here. So I have considered the same example, this example itself, ABCDE and ACE, right? So I have considered same example here. So first what we'll do here, we have to create the empty DP table. Means the first row and the first column are 0 here. So here you can clearly see this one I'm speaking of, first row and first column. So I have considered the first column, this one is first column, right? And first row, this one, first row and first column are 0 because an empty string has no common subsequence with any string. We are considering for the empty string. So we have already discussed this one. This was the base case, right? So an empty string has no common subsequence with any string, so it will be 0. Let's fill the other cells, right, in the table. So first row, comparing A from text 1 with text 2 here, this one, comparing A from text 1 with text 2 here. So we know that DP of 1 comma 1, this one we are considering, right? DP of 1 comma 1 equals DP of 0 comma 0, this one, A, right? Here it is nothing but here we can consider this one as 1. DP of 1 comma 1 as DP of 0 comma 0 plus 1 in this case, right? This will be 1 itself because 0 here, 0 plus 1 is 1, right? I hope this is clear, right? A matches with A here, so that is the reason we are going with this one. We are comparing 1 comma 1 with 0 comma 1. DP of 1 comma 1 is DP of 0 comma 0 plus 1. 0 plus 1 is nothing but 1 here in this case. That is why I have written 1 here, right? A does not match C, so we take maximum of DP of 0 comma 2 and DP of 1 comma 1 here. Maximum of 0 and 1 is nothing but 1, right? So this will be 1 here for 1 comma 2, and here again we will go with 1 comma 3 and 0 comma 3, right? Here so here A does not match with E, so we take max of DP of 0 comma 3, this one, max of DP of 0 comma 3 and 1 comma 2, and 0 and 1 max is 1. That's what we have written here in this case. So I hope this is clear. 1 and 1, how we got this one. Same we will be doing for every other thing, right? Every other cell in the table. So here we will compare B with B from text 1 and text 2, right? So here B does not match A, B does not match C, and B does not match E here in this case. This one I'm speaking of. B does not match A, B does not match C, B does not match E here. So we will just take the max here, right? Max of DP of 1 comma 1 comma DP of 2 comma 0. This one, 1 comma 1 and 2 comma 0, previous one. So this will be 1. Here max of DP of 1 comma 2 and 2 comma 1, 1 1. Max of 1 comma 1, this will be 1, right? So finally this one, max of 1 comma 3, this one I am speaking of, max of 1 comma 3 and max of 2 comma 2, again 1 1, this will be 1, right? I hope this is clear. Same goes with this one, C. Now we have to compare C from text 1 and text 2. C does not match A here, right? We can clearly see C does not match A, so we will take max of 2 comma 1 and nothing but max of DP of 2 comma 1 and 3 comma 0. This one, max of 2 comma 1 and 3 comma 0 will be considering 0 and 1. Max will be 1 in this case. This is clear. Now let's move on to this one, 3 comma 2. So here C matches C here. In this case, C matches C here. So C matches with C here. So max of we have to go with DP of 3 comma 3 2 equals DP of 2 1 plus 1. So 2 1, where is this one? 2 1, this one 1 plus 1 we will give here. This will be 2 in this case, right? So again, next step, this doesn't match, so we will go with max of 2 comma 3 and 3 comma 2. We have 1 comma 2 here, max of 1 comma 2 will be 2 here. So here we incremented because C matches C, right, in this case. So let's come to the next step, D here. So we have to compare D from text 1 and text 2. So here D does not match A, so we will take max of 3 comma 1 and 4 comma 0. 1 and 0, this will be 1 here. Again, D does not match C as well, we will take the max of this one 3 comma 2 and 4 comma 1. Here 2 comma 1, max of 2 and 1 will be 2 in this case, so 2 itself. So same goes with here. We will take max of, here D does not match E as well, right? So here max of 3 comma 3 and max of 4 comma 2, nothing but 2 comma 2, max of 2 comma 2 is 2 itself, right? So that's what we are going with here. The final step is we have to compare E here in this case. So E does not match A here. So max of 4 comma 1 and 5 comma 0, 0 comma 1 will be the max of 0 comma 1, that will be 1. Next E does not match C as well here in this case, right? E does not match C here, this will be max of 4 comma 2 and 5 comma 1, max of 2 comma 1, this will be 2, because max of 2 comma 1 will be 2 itself, right? So final step here is E matches E here. So this E matches with E, right? So C also got matched, A also got matched here. E matches with E. So what we will do, dp of 5 comma 3 equals dp of 4 comma 2, this one plus 1. We have to increment this one, this value plus 1, because E matches with E. So previous one, dp of 4 comma 2 plus 1 we will do. In this case answer will be 3, right? When it matches, we will go with the this one maximum value that we need to consider. This one 2 plus 1 we will go. 4 comma 2 is value we are having here is 2. 2 plus 1 will be 3 here. So we will return the last element, nothing but dp of 5 3 as the output. So this length here will be 3 in this case. So this is the approach that we will be going with. So this is the dp table implementation. So here the final answer, the answer is dp of 5 comma 3 that we got here is 3. So we have to return this one. This corresponds to the this one, longest common subsequence, nothing but ACE, right? So ACE equals ACE. So that's what we compared from ABCDE and ACE. Now ACE equals ACE. This corresponds to the dp of 5 comma 3. The length corresponds to the LCS. So we have to return 3. So this matches, the output matches the this one. Same thing here, whatever they have the output that they have given in the example, given for the example 1. So the approach works absolutely correct here. This is the approach that we'll be going with. I hope approach is completely clear. Next, let's discuss the edge cases one by one. So the first edge case that I'll be going with here is no common subsequence. So here we have different strings, right? Different characters within the string A, B, C, D, E, F. So no common subsequence at all. In this case, we'll be returning 0 because no common characters. So longest common subsequence length is 0 here. Next edge case that I'll be going with here is one string is a subsequence of the other. When I say one string is a subsequence of the other, text 1 ABC I have given, text 2 ABC I have given. Output will be 3 in this case because same characters we have. A matches A, B character, B matches B, C matches C here. So output will be 3 in this case. LCS is ABC itself. So I hope this is clear. The next one here is third one. One string is empty. Text 1 ABC, text 2 empty string. Text 1 ABC is fine. Text 2 here is empty string. When I say empty string, so either of the text 1 or text 2 is empty. Base case we have already considered. Either if it is empty string, then LCS is 0, right? So this one, an empty string has no common subsequence with any string. Here the output will be 0 for the condition one string is empty. Next, let's go with the fourth edge case, nothing but strings of different lengths. So here we have A, B, C, D, E, F, and we have ACE here. The output will be 3 because LCS is ACE here, right? So the output will be 3 in this case, right? ACE, ACE. We are ignoring or removing this one, B, D, and F here. So I hope this is completely clear. The first edge case that we went with here is, these are the 4 edge cases that we need to keep in mind. The first edge case we went with here is no common subsequence. The second edge case that we went with here is one string is subsequence of other. And the third edge case that we went with here is one string is empty. And the fourth edge case that we went with here is strings of different lengths. These are the edge cases that we need to consider. Right now, let's start writing the code. So here we will be making use of the length of the text1 and length of the text2 within the code. So instead of writing length text1 dot length every time, let's make use of the two variables and assign that one to text length of the text1 and text2, right? So let m equals text1 dot length and n I'll consider here text2 dot length. This is fine. So the next step here is we have to initialize the DP table of size m plus 1 into n plus 1, initially filled with zeros. We saw that one, right? Initialization of the DP table, if you remember in the approach, the first step that we considered, right? So that one. So how we will initialize the DP table here? Let me consider here array of n plus 1. Sorry, this one has to be m plus 1 into n plus 1, right? So this one array of, we are going with the 2D DP table, right? So let me give here fill map. This is fine. So this will be array of n plus 1. This is fine as well. So let's fill this one with 0. So I hope this is clear. So next step here is we have to fill the DP table using bottom up approach. When I say we have to fill the DP table with bottom up approach, so we saw that one, right? Entirely. So the table, if you remember. So how can we articulate that one in the form of code? Let's see the same thing. So I'll just go with the for loop here. For let I equals 1, I less than or equal to m. For the rows, let's increment I here. This is for the rows. So let's go with the column. Let j equals 1, j less than or equal to n. Let's increment the j here. This is fine. So if the characters match, then we have to extend the previous longest common subsequence. So here this one we saw during the approach by considering the previous this one, what do we call, cell in the table, right? So that we are going to articulate the same thing in the form of table. Simple if condition here, if text1 of I minus 1, this is, if it is equal to, we are comparing, right? Means the text in the text1, the characters in the text1 has to match the characters in the text2, right? So how can we write text of j minus 1 in this case? This is fine. So here if the characters match, then extend the previous longest common subsequence. Here this will be dp of I j will be dp of I minus 1. Here this will be j minus 1 plus 1. So what we did here, if the characters match, we are going to extend the previous LCS. Else what we will do, if the characters doesn't match, then we have to take the maximum LCS or the maximum longest common subsequence possible by ignoring one character at a time, right? So we saw that one. I have explained this one multiple times during the approach. So I'll just write here else dp of ij. So when characters doesn't match from both text1 and text2, when the characters doesn't match, we have to remove one character from either text1 or text2. That one I am articulating that one in the form of code. So I'll just give here math.max of dp of let me give here I minus 1 and j. So next one dp of, this is for the text1 and text2, right? So dp of I j minus 1. We are just articulating the same, the thought process in the form of code, right? So the logic one. So I hope this is clear. The final step, we have to return the final answer that is stored in dp of mn. This one, dp of mn. So I'll just come here. Let me give return dp of mn. This is fine. Let me format the code once and let me hit the run button. So here we are showing error. TP array is not defined. Oh, I have misspelled array here. Triple R I have given. So I'll just make this one to double R. So let me hit the run button again. Hope this works. No, text1 equals, oh, we have to compare with text2 right here, the line number 8. So I have just given text here. So this is fine. Let me run this one again. I hope this works now. Let's see. So yeah, you can clearly see the sample test cases are getting passed here. So let me hit the submit button quickly. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct in this case, right? So what will be the let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is dynamic programming. So the what will be the time complexity and the space complexity here? The time complexity would be here. The overall time complexity would be big O of m into n, right? The overall time complexity would be big O of m into n, because m and n here are the lengths of text1 and text2. We know this one right here. You can clearly see. So the overall time complexity would be big O of m into n in this case. So what would be the space complexity here? The overall space complexity would be big O of m into n as well. Why the space complexity here is big O of m into n? Due to we are storing the DP table, right? So due to storing of DP table, the overall space complexity would be big O of m into n. You can clearly see here. This one I'm speaking of. So overall time complexity and the space complexity for the code that we have written as big O of m into n. I hope this is completely clear, right? I hope the solution or the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.